Hey guys, welcome to your next lesson. And today we're going to learn that we can measure angles in a unit that's not degrees, right? So we're really good at measuring angles in degrees, but today we're going to learn this new unit of measure known as a radian. So just like you can measure the length of a table in inches, and you can also measure the length of a table in centimeters, you can measure angles in degrees, as we know, but you can also measure them in this new unit known as a radian. So today we're going to be talking about it, how to measure angles in radians. Okay, so let's start with a unit circle. So a circle's got a radius of 1. Okay, now I have an angle drawn here, and it looks like that angle is a little bit more than 45 degrees, maybe not quite 60, but pretty close to 60. But that's degrees. It turns out that this angle, has a very special measure in radians. So like I said, this is a unit circle, so the radius is 1. So I have this piece of string right here, and this piece of string has a length of 1, right? Because we can see, if I put it on the center, like this, the radius is 1. So the length of the string is 1. So we can go all the way around the circle. You can see that the radius is 1 everywhere on this circle. Okay. But if I take this piece of string, which has a length of 1, and let's say I start here, right? So all angles begin here. So then if I rotate it, let's say this far along the circumference of the circle, right? So if I go like this, along this arc, this far with my piece of string, notice that's 1. So that arc length is 1. So if I go exactly that far, it turns out that the angle we just made by doing that is 1 radian. So this angle is 1 radian. And I could go more than 1 radian. So it's 1 radian from here to here. If I do the same thing with my string, so this time I'll start where 1 radian is, the terminal side for 1 radian, and then I'll do another one of these, tracing along the circle. And if I do, I'm going to end up at this point over here. So I can think of another angle. Again, all angles start here. If I rotate that far, then this angle that has this terminal side, that would be 2 radians right there. And if I kept doing this with my piece of string that has a length of 1, that's 1 radian. This angle is 2 radians. This is where 3 radians would be, so 3 radians would be here. Now notice 3 radians is almost halfway around, but not quite. Right, so that's interesting. 3 radians almost makes it halfway around. This would be 4 radians here. In fact, let's mark this off. I'll put colors in here so you can see, okay, this is my 1 radian move here, right? And then this would be 2 radians, right? The 2 radians would be the angle that we make there. And this would be 3. And then 4 radians takes us to about here. So if I had a terminal side that went through here, that would be 4 radians. So 4 radians so far. 5 radians looks like it takes us just into the 4th quadrant. So this would be 5 radians from here to here. And if I go 1 more radian from here to here, this is how far 6 radians takes us. So 6 radians almost takes us all the way around the circle. So 3 takes us almost halfway. 6 takes us almost all the way, but not quite. We see there's some extra left over here. And there's a reason for that. If we think about circumference, the circumference of a circle, we know the formula for the circumference of a circle. The circumference of a circle is 2 pi r. By the way, you can also write it as pi d, right? You might have learned both of these. You probably learned both of these formulas, but you can see they're the same, right? Because the diameter is 2 times the radius. So they're the same formula, really. So what's the circumference of a unit circle? Well, for a unit circle, the radius is 1. So the circumference of the circle is 2 pi times 1. So the circumference is 2 pi. So what that means for my unit circle is that if I went all the way around, that would be 2 pi radians. And pi, we know, is 3.14, right? So 2 times 3.14, in other words, 2 pi, is 6.28. So it would take 6.28 radians to go all the way around. We know it takes 6 radians to get here. So we have 0.28 of a radian more, I guess. And that would get us all the way around a circle. So what we see here is that a full circle in radians is 2 pi radians. So 360 degrees and 2 pi radians are the same. And that's our starting point for radians. 2 pi radians is 360 degrees. And that's what we have a picture of here, right? So we have our terminal side. It rotates all the way around. And we all know that's 360 degrees. But as we've just learned, this angle is also known as 2 pi radians. So it's just another unit of measure, right? So we can say 2 pi radians is equal to 360 degrees. And usually we don't write the word radians. We just say 2 pi, and we understand we're talking about radians. Now, the next one over here, that's half a turn, right? Half a turn. We know that if we start here and we rotate half a turn, that's 180 degrees. But how many radians would that be? Well, if a full circle is 2 pi radians, a half circle would be half of this. What's half of 2 pi? Well, that's just 1 pi, right? So this angle that we've drawn here in radians is pi. So this is pi radians. So we can see here that pi, or pi radians, is the same thing as 180 degrees. So now we have another way of measuring that half turn, pi radians. Okay, now let's take a look at this one here. We all know that this is a 90-degree angle right here, but that's degrees. What would this angle be in radians? Well, 90 degrees, of course, is halfway to 180. So if we're in radians, we're halfway to pi. So in other words, half of pi. So this would be 1/2 pi radians, but we usually don't write it this way, 1/2 pi. We write it as 1/2 times pi, which of course is pi over 2. So pi over 2 radians is what we have here. So now we've just learned that pi over 2 in radians is the same thing as 90 degrees. And that's going to be a really important one for us to know. So pi over 2 is 90 degrees. Now we have this one. So here we start here, of course, and we rotate 3/4 of the way around. We all know that's 270 degrees. But what is that in radians? Well, watch how we figure this out. Remember I said pi over 2 is 90 degrees, right? So if I start here, this is pi over 2 radians, right? 90 degrees. That's 1 pi over 2. But if I go another pi over 2, that's going to be 2 pi over 2. And of course, 2 pi over 2 is the same as pi. That makes sense, right? Because half a circle is pi. So again, if we start over, 1 pi over 2 radians. This is 2 pi over 2 radians. So this must be 3 pi over 2 radians. So this angle right here is 3 pi over 2. So what we see here is that 3 pi over 2 radians, that's the same as 270 degrees. And by the way, if I went all the way around the circle, pi over 2 radians each time, in other words, 90 degrees each time, check this out. That's 1 pi over 2. That's 2 pi over 2, otherwise known as pi. That's 3 pi over 2. And this would be 4 pi over 2. Well, what's 4 pi over 2? Well, that's 2 pi. That's a full circle, 2 pi radians. Okay, so now let's break down this even further into like 30 degrees, what that's in radians, 45, and so on. And that's coming your way next. Okay, so let's see if we can write some of these very common angles, 30 degrees, 45 degrees, 60 degrees. Let's see if we can write these angles in radians. And let's see if we can get there by using this knowledge right here. Pi over 2 is 90 degrees. So we've seen that. So pi over 2 is the same as 90 degrees. So what would 30 degrees be? Well, clearly 30 degrees, right? This is 1/3 of 90, right? And since 30 degrees is 1/3 of 90, it should be 1/3 of what 90 degrees is in radians, which is pi over 2. So what's 1/3 of pi over 2? As you know in math, when you see of, it means multiplication, right? So 1/3 of pi over 2 is like 1/3 times pi over 2. So it's going to be pi over 6. So 30 degrees is pi over 6 radians. So 30 degrees is pi over 6 radians. Now, that should make sense to us also because not only do we know pi over 2 is 90 degrees, we also know that pi is half a turn, right? So pi is 180. So if you just think of pi as 180, 180 divided by 6, there's your 30 degrees. So 30 degrees is pi over 6 radians. That's something we're going to want to know. 45 degrees, well, what's that? Well, 45 degrees, of course, is half of 90. Right, so that's half of 90. So it's half of I don't need that over there. It's half of 90 degrees, which is pi over 2. Of means multiply, so 1/2 times pi over 2. So we get pi over 4. So 45 degrees is another one we're going to want to know, is pi over 4 radians. Now, how do we get to 60 degrees? Well, let's think about that. 60 degrees is twice 30 degrees, right? So 60 degrees is 2 times 30. So it's going to be 2 times whatever 30 degrees in radians is, and we just figured that out. It's over here. It's pi over 6. So 2 times pi over 6, and of course the 2 becomes a 1, the 6 becomes a 3, and we get pi over 3. So it looks like 60 degrees is pi over 3 radians. And again, we could use that fact that pi is 180 degrees, right? So if we just replace pi with 180, 180 divided by 3, there's your 60. By the way, it works here too. So if pi is 180, 180 divided by 4 is 45 degrees. But these very common angles, we're going to want to know what their equivalence is in radians. So we want to know that 30 degrees is pi over 6 radians. We want to know that 45 degrees is pi over 4 radians. And we want to know that 60 is pi over 3 radians. So those are going to be things you just want to know, okay? And we're going to see how we use them. Notice I've written them over here. Very important. Pi over 6 is 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. And again, if you remember, pi is 180. 180 divided by 6 is 30. 180 divided by 4 is 45. 180 divided by 3 is 60. Okay, so we're going to want to know those. And it's going to be very helpful because we'll be able to figure out a whole bunch of different angles by doing what we're about to do. So here, I'm rotating by pi over 6. Well, what's pi over 6? Well, that's 30 degrees. So here, what I'm doing is I'm starting here at 0 degrees, and then I'm rotating 30 degrees each time. So if we were measuring in degrees, we would go, that's 30 degrees, that's 60, that's 90, 120, 150, 180, 210, 240, 270, 300, 330, and then 360, right? That's degrees. But we can count in radians, and believe it or not, it's actually easier to count in radians. Well, first, I didn't mention it before, but 0 degrees is the same as 0 radians. So this would be 0 radians right here if I did this angle. If I went this far, that angle would be 30 degrees, but in other words, pi over 6 radians, right? Notice that's 1 pi over 6. So if I go 30 degrees, that's 1 pi over 6 radians. If I go another pi over 6, that's 1 pi over 6, that's 2 pi over 6. So this is 2 pi over 6 radians. If I go another pi over 6, this is 3 pi over 6. If I go another pi over 6, this is 4 pi over 6. So you see how easy it is to just add pi over 6 each time. Here I'm at 5 pi over 6. And then here, 1 more pi over 6 gets me to 6 pi over 6. So we're halfway around. This is 7 pi over 6 radians right here. Another pi over 6 takes me to 8 pi over 6. Another pi over 6 takes me to 9 pi over 6. And then 10 pi over 6. And then 11 pi over 6. And then a full circle, which is 12 pi over 6. Now, as I'm writing these fractions, you are probably realizing that a lot of these can be simplified. And of course they can. 2 pi over 6, that's the same as pi over 3. Which makes total sense, right? Because that's 60 degrees. As we've seen, pi over 3 is 60 degrees. Also, 3 pi over 6, that can be simplified also. That's pi over 2. That makes sense. Pi over 2 is 90 degrees. If we go here, that's 4 pi over 6. So that can be simplified. So we're going to write that as 2 pi over 3 radians. 5 pi over 6, we can't simplify that. But check this out, 6 pi over 6, that's pi radians, which makes total sense. Pi is half a circle. 7 pi over 6 can't be simplified, but 8 pi over 6 can. This is 4 pi over 3 radians. This can be simplified. 3 goes into both, so this is 3 pi over 2 radians. That also makes sense because we saw earlier that 3 pi over 2 radians is 270 degrees. This can be simplified into 5 pi over 3 radians. This can't be simplified, but what about this? 12 pi over 6, that's 2 pi, and of course that makes sense. We know a full circle in radians is 2 pi radians. So being able to count by pi over 6 is going to be very helpful for us as we start working with angles with radians. So just like we can rotate by pi over 6 like we did here, so we were rotating by pi over 6, we can also rotate by pi over 4. So let's do that next. Pi over 4, that's 45 degrees. So we're going 45 degrees each time. So here, in terms of degrees, that's 45 degrees, that's 90, that's 135, that's 180, that's 225, that's 270, that's 315, and that's 360. So those are the familiar angles to us in terms of degrees. But we can also go by radians. So we start with 0 radians. If we go this far, that's pi over 4 radians. 1 pi over 4. This would be 2 pi over 4. So this is 2 pi over 4 radians. Another pi over 4 takes me to 3 pi over 4 radians. Another pi over 4, 4 pi over 4. Another pi over 4, 5 pi over 4 radians. 6 pi over 4 radians. Another pi over 4, 7 pi over 4. And then a full circle would be 8 pi over 4 radians. Obviously, these can be simplified, or at least some of them can. 2 pi over 4, what's that? Pi over 2. Of course it's pi over 2. We know pi over 2. That's 90 degrees. Okay, 3 pi over 4, can't simplify that. What's this? 4 pi over 4. Well, that's pi. That makes sense. That's a half turn, pi radians. We got 5 pi over 4 here, but here, 6 pi over 4, what does that simplify to? No surprise. 3 pi over 2 radians. We know that one. That's 270 degrees. And of course, what's this? 8 pi over 4? As expected, the full turn. That's 2 pi radians. So we can count by pi over 6s. We can count by pi over 4s. We can also count by pi over 3s. So let's do that next. So let me erase this here. And let's count by pi over 3s. I think I said pi over 3. That's what I meant to say. We're going to rotate by pi over 3s. Okay. So let's do it. We get our x and y axis here. And remember, pi over 3 is 60 degrees. So we're basically rotating by 60 degrees each time. So now we're rotating by pi over 3, or 60 degrees. Okay, so we should know what 60 degrees looks like, right? If I could start here, 60 degrees is like this, right? So this would be 60 degrees, otherwise known as pi over 3. Now we got to be careful here. If I'm going by 60 degrees, if I go by another 60 degrees, I'm not pointing straight up because that's only 90, right? So if this is 60, another 60 added to that would be 120, which would put me somewhere around here-ish. So there's your 60, 120, and then 180. So now we're pointing straight left like this. So 60, 120, 180. Another 60 would take me here, which is like 240. But again, if you add 60 to that, you go past the y-axis over here to 300, right? 240 plus 60. So now we're going to be at 300 over here. And then finally, we're back at 360 when we do this. Okay, but in terms of radians, what are these angles? Well, we start with 0 radians. We went 60 degrees each time. 60 degrees is what? That's pi over 3. So that's 1 pi over 3. So when I go another 60 degrees, that's 2 pi over 3. Another 60 degrees, another pi over 3, right? So this is 1 pi over 3, 2 pi over 3. This is 3 pi over 3. 3 pi over 3. Here is 4 pi over 3. When we swing over to here, we add another pi over 3. So this is 5 pi over 3. Let me write that so you can actually read it. That's 4 pi over 3. 5 pi over 3, and of course all the way around, 6 pi over 3. Of course, 3 pi over 3, that's pi, makes sense. That's a half a turn. 6 pi over 3, that's 2 pi. That also makes sense. That's a full turn. So if we get good at rotating by pi over 3 each time, or pi over 4 each time, or as we did earlier, pi over 6 each time, it's going to be really helpful because now we're going to start taking the sine and cosine of angles measured in radians. Coming your way next. Okay, so now we're ready to find sine and cosine of angles given to us in radians. So we're going to evaluate each of these. The first one is the sine of pi over 6. So we have to know pi over 6 is what? Well, let's see, that's 180, right? Pi, so 180 over 6, that's 30. But we should know that pi over 6 is 30, right? So when you're doing the sine of pi over 6 radians, that's exactly the same thing as saying you're doing the sine of 30 degrees. So if we were drawing an angle of pi over 6, it would just be like 30 degrees. So pi over 6 is here. So we just want to find the sine of this angle, pi over 6. And like I said, it is the same thing as the sine of 30 degrees. And that's one of the values we should know, right? So the sine of pi over 6 is the sine of 30. That's 1/2. So it's that simple, right? If we know pi over 6 is 30 degrees, the sine of pi over 6 radians is the same as the sine of 30. So that's going to be 1/2. The sine of pi over 4. What's pi over 4? Well, 180 divided by 4 is 45. Or you can just memorize pi over 4 is 45 degrees. So what does pi over 4 look like? Well, it looks exactly the same as 45 degrees because it is the same, right? So this is pi over 4 radians. So the sine of pi over 4 radians is the same as the sine of 45. And we know that one, the sine of pi over 4 radians is rad 2 over 2, because when you're asked for the sine of pi over 4, it's the same as saying the sine of 45 degrees. Okay, what if we're outside quadrant 1, like we are with this one, 7 pi over 6? This is where counting by pi over 6s is going to help. So we draw our picture. First, we know we're going to go 7 pi over 6s, but we have to know what pi over 6 is, right? And pi over 6 is 30 degrees. So watch as we rotate here. That would be 30 degrees. In other words, 1 pi over 6. Another 30 degrees. That's 2 pi over 6. That's 3 pi over 6. 4 pi over 6. 5 pi over 6. And now 6 pi over 6, which makes sense. That's pi radians. 7 pi over 6 would be here. So this is what an angle of 7 pi over 6 radians looks like. So my angle here is 7 pi over 6 radians. But just like we used reference angles when we worked with degrees, we can do the same here. So this was 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So what's the reference angle in radians? Pretty simple, actually. It's just pi over 6. So we're going to use the same concept that we used before, using the reference angle, but this time just in terms of radians, that's all. So we're going to say sine of 7 pi over 6 is equal to, leave a space, the sine of its reference angle, pi over 6. Because it's either equal to sine of pi over 6 or the negation of the sine of pi over 6. What tells us, of course, is ASTC. This angle, the terminal side of the angle, is in quadrant 3. In quadrant 3, sine is negative, so it will be the negation of sine of pi over 6. Therefore, sine of 7 pi over 6 is just the negation of what sine of pi over 6 is. Remember, pi over 6 is 30, so that's like the sine of 30. We know the sine of 30, that's 1/2. Therefore, the sine of 7 pi over 6 is the negation of that, so the sine of 7 pi over 6 is negative 1/2. Okay, let's do some more. All right, the first one up here is cosine of pi over 3, right? Pi over 3, that's 60 degrees, right? Here it is, pi over 3, 60 degrees, right? If pi is 180, 180 divided by 3 is 60 degrees. So we should know that pi over 3 is 60. So an angle of pi over 3 looks like an angle of 60 because it is, right? It's the same thing. So if someone asks us to do the cosine of pi over 3, it's really the same thing as the cosine of 60. And that's a cosine value we're supposed to know, right? Cosine of 60. So let's say we're going down from 1. So 1, rad 3 over 2, rad 2 over 2, 1/2. So the cosine of pi over 3, like we said, it's just the same thing as the cosine of 60. So the cosine of pi over 3 is just 1/2. Next up, I have the cosine of 7 pi over 4. Okay, so here we're going to count by pi over 4s to get to this angle, 7 pi over 4. Pi over 4 is 45 degrees. Again, something we should know. So let's count by pi over 4s. This is 1 pi over 4 is your 45 degrees. That's 2 pi over 4. 3 pi over 4, 4 pi over 4, which is pi. 5 pi over 4, 6 pi over 4. There's your 7 pi over 4 right here. So this is your angle of 7 pi over 4 radians. We're just counting pi over 4, in other words, 45 degrees at a time. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. There's your 7 pi over 4. Again, we're going to use our reference angles. So this reference angle is what in radians? Well, that should be pretty easy, right? Because I only have to go another pi over 4 to get to the x-axis here. So the reference angle is pi over 4. So how do we do this? Well, we say cosine of 7 pi over 4 is equal to, leave a space, cosine of its reference angle. And its reference angle is pi over 4. It's either equal to the positive cosine pi over 4 or the negation of cosine pi over 4. What tells us is our friend ASTC. We're in the fourth quadrant. Cosine is positive there. So it is going to be the same as the cosine of pi over 4. And remember, pi over 4 is the same thing as 45 degrees. So do I know the cosine of 45 degrees? In other words, do I know the cosine of pi over 4? I sure do. It's rad 2 over 2. So therefore, the cosine of 7 pi over 4 is also rad 2 over 2. Okay, 5 pi over 6 is next. It looks like we're going to be counting pi over 6s to do this one. So we do it. We know pi over 6 is 30 degrees. I want to get to 5 pi over 6. I'm going 30 degrees each time. So there's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Looks like 5 pi over 6 will be here. So there's our angle of 5 pi over 6 radians. How far from the x-axis are we? I think we know. That's pi over 6 away. So that's our reference angle. So if I'm doing cosine of 5 pi over 6, the cosine of 5 pi over 6 is going to be equal to, leave a space, cosine of its reference angle, which is pi over 6. We leave a space because it might not be equal to this. It might be equal to the negation of this. And what tells us is our friend ASTC. So in quadrant 2, cosine is negative. So it will be the negation of cosine pi over 6. So if I know the cosine of pi over 6, I'm in business. Because the cosine of 5 pi over 6 will be the negation of that. Well, pi over 6 is 30 degrees, right? So the cosine of 30, see that one starts at 1 and goes down. That's rad 3 over 2. So the cosine of 5 pi over 6 will be the negation of that. So it's going to be negative rad 3 over 2. So there's your cosine of 5 pi over 6. Next up is the cosine of 2 pi over 3. Notice, as we've seen before, sometimes they put it in parentheses, sometimes they don't. But it means the same thing. We're doing the cosine of 2 pi over 3. So now we're going to count pi over 3s. Pi over 3 is 60 degrees, right? So I'm going to go 60 degrees at a time. Here's 1 pi over 3. Now 2 pi over 3 is not pointing straight up, right? Because I'm going 60 degrees at a time. So think of it as like 120, right? So 1 pi over 3, 2 pi over 3, which is in the same exact spot, of course, as 120 is, 120 degrees. So there is your angle 2 pi over 3. We need the reference angle. This is 1 pi over 3. That's 2 pi over 3. That would be 3 pi over 3. So I think it's clear that the reference angle here is pi over 3. So how do we do the cosine of 2 pi over 3? Well, the cosine of 2 pi over 3 might be the same as the cosine of its reference angle. If it's not, it's got to be the negation of that. So cosine of 2 pi over 3 is equal to, leave a space, cosine of pi over 3. We're in the second quadrant. Our friend ASTC tells us that in the second quadrant, cosine is negative there. So cosine of 2 pi over 3 will be the negation of cosine of pi over 3. So if I know the cosine of pi over 3, I'm in business. Remember, pi over 3 is 60 degrees. Do I know the cosine of 60 degrees? Let's see. 1, and then rad 3 over 2, rad 2 over 2. It's going to be 1/2. So the cosine of 2 pi over 3 is the negation of that. So there's your negative 1/2. So the cosine of 2 pi over 3 is negative 1/2. Okay, coming your way next, I'm going to show you an easy way to go from a radian angle into degrees, and that's coming your way next. Okay, so let's look at a nice easy way to convert an angle from radians into degrees. So like it says here, to convert from radians to degrees, you just have to multiply by this magic fraction here, 180 over pi. And if you do that, it'll take your radian angle and it'll tell you exactly what it is in degrees. So we're just going to multiply by 180 over pi. All right, so the first one up is 7 pi over 4. And again, we're simply just going to multiply by this. And when we do that, we'll get this angle in degrees. So 7 pi over 4. We take it, we multiply it by that magic fraction, 180 over pi. Of course, when we multiply fractions, things cancel. In this case, the pi's cancel. They become 1s. And 4 goes into 180. 4 goes into 180 45 times. So now we just have 1 in the denominator. So we just do 7 times 45. And 7 times 45 turns out to be 315 degrees. So it's not that easy to, I guess, multiply 7 times 45, but you can work it out. It's 315 degrees. So that's the answer. So 315 degrees is the same as 7 pi over 4 radians. For 5 pi over 6, we do the same thing. So we just take 5 pi over 6, multiply by that magic fraction, 180 over pi. This one's going to be easier, I think. The pi's cancel, just like they did here. And now 6 becomes a 1, 180 becomes a 30. So 5 times 30 is 150 degrees. So 5 pi over 6 is the same as 150 degrees. However, I think there's an easier way to get both of these than even this. And that's by counting, right? Like we have been doing. So I can count by pi over 4s. And if you know pi over 4 is 45 degrees, that's 1 pi over 4, 2 pi over 4, 3 pi over 4. There's your 4 pi over 4. That's pi. 5 pi over 4, 6 pi over 4. Here's 7 pi over 4. And what is that in degrees? Well, we know what that is, right? That's 270 plus another 45. It's 315. So you can actually get there without doing this, right? If you just draw the picture and you know pi over 4 is 45 degrees, and you just count. We could do something similar here. So I can count by pi over 6s. So if we know pi over 6 is 30 degrees, I can go by pi over 6 each time. So there's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So we're pi over 6 away from the x-axis, in other words, 30 degrees away. So we know that's 150 degrees, right? So I think it's actually easier if you just draw the picture and count, right? But of course, you do need to know pi over 6 is 30. You need to know that pi over 4 is 45. Now, remember at the beginning of class, I drew that angle, which was 1 radian, right? And it was a little bit steeper than 45, maybe not quite 60, right? It was 1 radian. And you saw how I did it with the string and all that stuff, right? But now that we know this, I can actually see how many degrees that actually is, right? We said it was like almost 60, I guess. So you just take 1, right? That's in radians. So you take that and multiply it by this, 180 over pi. So weirdly, I guess, the answer here is 180 over pi degrees. But you can use your calculator, and I have a calculator right here, and if you did this, and you just did 180 divided by pi, you would actually get 57.3 degrees. So that 1 radian I drew at the very beginning of this lesson was actually an angle of 57.3 degrees because that's what 1 radian turns out to be. Okay, last question. Let's say we had to evaluate the sine of 3 pi over 2. Okay, as we know, we always begin with a picture. So let's do the picture. And obviously our first challenge is to figure out where 3 pi over 2 radians is. So I can count by pi over 2s, right? Because pi over 2 is 90, right? So this is 1 pi over 2. This is 2 pi over 2, in other words, pi radians. Here's our 3 pi over 2. So that's one way you can do it. Or you just might remember, we looked at this before, 3 pi over 2 is the same as 270 degrees. So this is my angle of 3 pi over 2 radians. And also remember this, we've talked about it. If you end up on an axis, like this angle does, you want to think unit circle right away. So that's what we're going to do. We draw the unit circle right away. We know the point on the unit circle that this passes through is the point 0, -1. And we know on a unit circle, sine of theta is equal to the y coordinate on a unit circle. So quite simply, the sine of 3 pi over 2 is going to be this y coordinate. So the sine of 3 pi over 2 turns out to be -1.